Hello guys and girls, this is Mrs. T. I am going to go over AIM 1 and AIM 2 from the Moles and Stoich AIM sheet. So if you could make sure that you have your AIM sheet available, you should also have a calculator, you should also have your reference tables. I'm going to take you through some of the questions from AIMs 1 and 2 as a review. So we're going to go over finding the gram formula mass, and converting between moles and grams, which we learned in class already. For those of you who don't know me, who are joining me and you're not one of the members of my class, I'm Mrs. Tominello. I'm a chemistry teacher at Calhoun High School in Merrick, New York. Hopefully gram formula mass. And gram formula mass also can be known as the molar mass. So since we're finding the mass of 1 mole, sometimes we call it the gram formula mass, sometimes we call it the molar mass. And if we want to find the gram formula mass of CH2, the first thing we're going to do is look on the periodic table, and we're going to find carbon and hydrogen. We're going to look at these average atomic masses, and we are going to take those numbers and we're going to round them to the nearest tenth. So for carbon, we're going to use 12.0. For hydrogen, we're going to use 1.0. Then we're going to look at these subscripts down here. Remember, carbon has an understood subscript of 1, so I'm going to do 12 times 1. Hydrogen has a subscript of 2, so I'm going to do 1.0 times 2. My results are 12.0 and 2.0, which means that for CH2, 14.0 grams would be the mass of 1 mole. For C6H12O6, we're still going to look at these numbers. We're going to look at carbon, hydrogen, and oxygen. Again, we're going to find those on the periodic table in your reference tables. And this time, instead of doing carbon times 1 and hydrogen times 2, we're going to do carbon's mass on the table times 6 because of the subscript of 6. We're going to do hydrogen's mass on the table times 12 because hydrogen has a subscript of 12, and oxygen's mass on the table times 6 because oxygen has, we're going to round them to the nearest tenth. 12.0 times 6 is 72.0. 1.0 times 12 is equal to 12.0. And this 15.9994 becomes a 16.0, and 16.0 times 6 is going to equal 96.0. When we add all of these numbers together, we're going to get 180.0, and we're going to write that many grams equals 1 mole for C6H12O6. And remember, when we're talking about this mole, okay, a mole is going to be the number of molecules that contains, no it's not, I'm sorry, it's going to be the mass that contains 1 mole of molecules, and 1 mole is going to be the amount of molecules, that is 6.022 times 10 to the 23rd. So this is Avogadro's number, and this is the number of molecules in 1 mole of any substance. If we wanted to find something for a gram formula mass of something with parentheses, remember that these parentheses will distribute. So the 2 on the outside means that we're going to multiply the mass of N times 2 and the mass of H times 8 because we do the 2 times the 4. The S and the O are not in the parentheses, so we're going to multiply the mass of S times 1, and we're going to multiply the mass of O times 4. To the nearest tenth, N is 14.0. To the nearest tenth, hydrogen is 1.0. To the nearest tenth, Sulfur is 32.1 because the 6 bumps the 0 up, and to the nearest tenth, 15.99 is going to be 16.0. So this is going to be 28.0 plus 8.0 plus 32.1 plus 64.0 and we're going to get, for the gram formula mass, 132.1 grams equals 1 mole. So that means that if we wanted to have Avogadro's number, or 6.022 times 10 to the 23rd molecules of this substance, we would need 132.1 grams of the substance. Moving on, once we know the gram formula mass, that's the mass of 1 mole. So if we want to find out how many moles are contained in a different mass, or what the mass would be for a different number of moles, we're going to use this formula. And this formula is found on table T. Okay, remember that table T is that last table on your reference table. And on this table right here, on the back of the reference table, you're going to find your mole calculation formula. So if we wanted to find out how many grams for 5 moles of MgBr2, we're going to write the formula, number of moles equals given mass over the gram formula mass. And we're going to say, okay, well, the first thing we need to know is what is the mass of 1 mole of MgBr2. So we're going to do Mg times 1, Br times 2. We're going to round to the 10th before we do that. So this to the nearest 10th would be 24.3. This to the nearest 10th would be 79.9. And 79.9 times 2 is 159.8. When we add them together, we find out that the mass of 1 mole is 184.1 grams. So if we want to know how much is 5 moles, we're going to do 5 moles equals X over 184.1 grams, which really means that we're going to be multiplying 5 times 184.1. So you're going to take the number of moles that you want, and you're going to multiply by the gram formula mass, and that'll give you the new mass. And my new mass comes out to, sorry about that, 920.5 grams. That would be my final answer. Because I found the mass of 1 mole, if I wanted 5 moles, I just multiplied the number of moles by the mass of the number of moles that I wanted times the mass of 1 mole, which is the gram formula mass. If we wanted to do instead, we wanted to use that formula, number of moles equals given mass over gram formula mass. To convert from grams to moles, we're going to plug in the number of moles as X, because that's our question mark. And we're going to plug in the given mass, which is the mass that they actually gave us, which was 26.25 grams of Fe. We're going to put it over the gram formula mass, which on our table for iron is 55.8. When we divide 26.25 by 55.8, we get 0.47, and that is the number of moles of iron contained in this mass. If instead we want to do the next example, number of moles equals the given mass, which is this grams, remember grams are mass, 0.156 grams of Be, over the gram formula mass on the table. Oops, I'm going too fast, hold on. The gram formula mass on the table, which is 9.0 grams of Be, And if I do 0.156 divided by 9.0, I get a very small number, which is 0.017 moles of Be, which would be contained in this very small mass. Remember that numbers aren't either right or wrong just because they're really small or really big. It's whatever number comes out of your calculator could possibly be the right answer if you've plugged in the right numbers. A lot of people say, oh, that just doesn't look right. Again, if we want to do how many moles, we're going to use the formula. Number of moles equals given mass over the gram formula mass, which means that now that we're talking about a compound, we have to use these numbers to the nearest tenth to find the gram formula mass first. We have to add that up to get our mass that equals 1 mole. That will be our gram formula mass. So Li times 1 is 6.9. F times 1 is 19.0. The total mass for that would be 25.9 grams equals 1 mole. They want us to use the givens of 53.7 grams and put it over the gram formula mass of 25.9 grams to get a number of moles. I calculate the answer, and this comes out to 2.07 moles. How do I know it's moles? Because I was solving for a number of moles. I had a given mass, I had a gram formula mass, which means my answer comes out in moles. For CaCl2, again, in order to calculate a number of moles for a compound, when you're starting with grams, you first need the gram formula mass. Calcium to the nearest tenth is 40.1. Chlorine to the nearest tenth is 35.5 times 2 is 71. So this is going to be 111.1 grams equals 1 mole. And if we have 16.58 grams, number of equals given mass over gram formula mass. And when I divide it out to get the number of moles, I get X equals 0.149 moles. Finally, if we wanted to do one more like this, now this time again we're starting with moles. Remember, starting with moles, you multiply by the mass for 1 mole. When we did C times 6, H times 12, and O times 6, remember we rounded all these to the nearest tenth from the table, which was 16.0, 1.0, and 12.0. Then we multiplied by all these numbers, and we got the gram formula mass of 180.0 grams equals 1 mole. We're going to do number of moles equals given mass over the gram formula mass. But again, remember this time the given mass is our X. So we're going to do 2.6 moles equals X over 180 grams. And 2.6 times 180 was 468. So this would be the mass for our final answer. So hopefully going back over some of these problems from the AIM sheet has helped. And again, remember that this was AIM 1 and 2. If you have any other questions, feel free to come to Extra Help or ask me some questions in class, and have a good day.